Everyone, welcome back to Java Programming. In this video, I'm going to talk about Java interfaces. And one thing I should say right up front is that by interface here, I don't mean a graphical user interface or a GUI or windowing type application or anything like that. Instead, let's talk about what I do mean. We'll just set a little background here to start off. So if we think back or take a look at our inheritance tree that we've been working with for the last couple chapters with our animals, let's think about in our application or in our story that we have with our animals, we now want to be able to identify some animals as pets. So maybe we want to use the animal class and related classes in a veterinary application, for example. So if I wanted to add the capability to identify some animals as pets, what would I do? And if we scroll down just a little bit, we've got some of the options here. So you might think, well, let's just put an isPet method maybe on animal. But maybe there are going to be some different pet type methods that we're going to want, like plays or something like that, chases ball, whatever that might be. That doesn't really fit on animal necessarily, right? Because the implementations might be different. So we might think, well, I'll put a method on animal class, but I'll make it abstract. What happens then is that now I'm forcing, say, the hippo to have a pet type method implemented where it really isn't going to make sense. And then maybe what we do is just add some pet type methods on the classes where it makes sense to have them, like cat and dog in this case. The thing is, we could end up with some duplicate code there. So what do we do, or how do we solve this problem? Well, because we can't just have a pet class that we also implement, and that might also extend, and that might have been another solution that kind of came to mind, is we'll just create a pet class and then say dog extends animal and it extends pet. Well, in Java, we can't do that. We can only extend or subclass from one class. So that leaves us with a bit of a problem, and the answer to that is an interface. So an interface is kind of a special class, if you will, that allows us to have methods available to classes that aren't necessarily just directly inheriting from a class. So I have methods that aren't on animal, they're going to be on an interface, and I can have many interfaces that are implemented by my classes. So that kind of gives us the ability to have lots of different stuff fed into a particular concrete class. So more about interfaces here. An interface is like a contract. So just like we had with the abstract methods, we were able to force the compiler to make sure that my concrete classes implemented a particular method. We can do the same thing with an interface. So the compiler is going to enforce those rules that we're setting up in that interface. An interface is going to look just like a class. It's just that we're going to have a new keyword interface that we use rather than class. Still have a .java extension, and the code inside of there is going to look a lot like a class, but we're going to have a lot of abstract methods in those. One big difference, and here it is, that interface keyword. That's the big difference. That's it. So rather than public class pet, we have public interface pet, and then we have our abstract methods. Now, one thing that I want to note is that in this introduction, we're going to assume that interfaces only have abstract methods. In Java 8, this changed, and you can actually have what we call default methods in an interface. It's not something we're going to talk about or work with at all in this class, but we will explore that in advanced Java. So because it's new, we didn't want to mix that in quite yet. A lot of companies aren't even on Java 8, but yet it's an important concept, and so we're gonna talk about that in advanced Java. So the cool thing about interfaces is that a class can implement not just one interface, but multiple interfaces. So it's a little different than inheritance, that superclass subclass relationship where we could only inherit from one class. Here we can implement many interfaces, so that allows us to bring all kinds of functionality into a given class. So again, why do we want to do this? It's about polymorphism and being able to treat objects many different ways. So back to our dog class, we could treat that dog as an animal, as a canine, as a dog, and now we could treat it as a pet. So we could use pet as our type, and then that would give us the capability or methods available on my dog would be anything that's in pet. Think back to the snowboard object diagram. The same thing is going to hold true if this is an interface versus a superclass. It is this type that controls what methods are available on the object reference variable. So let's jump over into our vehicle demo again and add in an interface and see what implications that has for application and how we can work with that. And then you'll be all set to work on Lab 7 and really finish up this unit and move on to the project as well, which I'll be back to talk about in another video. Okay, so let's pick up with our vehicle. And the main classes that I'm going to use here are the vehicle factory, because we have an array list there of those, and we'll work with our car and airplane. What I want to do is add an interface though. And so an interface, a lot of times we think of these as one of the common interfaces that you'll use in Java is comparable. A lot of times interfaces end with able. So we can do something like compare. And so all objects, you can think of all classes that we might want to be able to compare those. And so there's a comparable interface in Java that's used for things like sorting. So that might be one that you take a look at in addition to the interface that we're going to write from scratch. So the interface we're going to write is maintainable. So if we think about lots of different things that we own that probably need to have some kind of maintenance on them, including our vehicles or our airplane or our car. It could range over to other things like our HVAC systems. They need to be maintained, right? So maintainable might be an interface that gets used across many different systems and problem spaces. So it's not just specific to vehicles. So interface is a lot of times much, much more broad. So let's take a look at writing that interface. I'm going to add this into our design document. And so we're going to have a new interface called maintainable. And the purpose of this is going to be to figure out how much it costs to maintain my vehicle. And so just a little blurb here on the method. We'll have a method here called something like, I don't know if we should do, I think it will do something related to a cost probably on this. So let's just call it get, or maybe determine maintenance cost. And again, a long method name that I might regret, but we'll do some copy and pasting there. And so that determine maintenance cost, I'm going to define that in my interface, and that means that any of my classes that implement maintainable will have to write code or have code for determining that maintenance cost. And that would vary quite a bit by whatever is implementing maintainable. Again, for an HVAC system, that's pretty different than how we might determine what the maintenance cost is on a car, for example. So let's go ahead and write the interface. We'll add this method in there, and then we'll implement that interface in our car and see what happens in terms of the compiler and what we need to do to make the compiler happy. So we'll add a new class here, or a new file into demos, which will be an interface. And we'll call this maintainable.java. And I don't remember if Atom has a snippet with that plugin for interface, so we'll test that out. I don't think it does. It had one for class. So we'll just write this out. So public interface, and then the name maintainable. And then the rest of writing the interface looks just like writing a class. So we've got curly braces. We'll put our comments up here. For any item that has, or that needs to be maintained. So that's kind of general, but it'll work for now. author name. So in terms of JavaDoc or documentation on an interface, it's going to look just like it does on our classes. And I just realized I have a typo here, interface. That looks a little bit better. And let's go ahead with our first method then. We'll get a comment in here, and we'll only have the one method that we come up with in the design. So determines the cost of maintenance. And I think it makes sense for this to return a value, so we'll have an @return. Which is the maintenance cost. Spell check's not being kind to me, or it's being too helpful today. All right, and then let's write that method, and remember it's going to be abstract. So public abstract, the type that gets returned is going to be a double since it's a cost. And then the method name, as we mentioned, or as I defined here, determine maintenance costs. So I'm just going to grab that. And we'll pop that in here. It ends with a semicolon. So remember, abstract methods, we don't have curly braces, we don't put any code in there. I'm just setting up the contract for any other classes that do implement maintainable. I'm defining that they have to have this method implemented. You'll notice that I do have good JavaDoc comments on here, and that's important because sometimes I'm writing an interface and there aren't any classes yet that implement that. It is this comment that's going to let the developer know what the heck this method is supposed to do. So very, very important that we document our interfaces just like our other classes. So let's go ahead and save that. Save up our design, and let's go ahead and compile and make sure we haven't made any mistakes with our interface. Compile looks good, and we haven't done anything with it yet, so there's really nothing to run at this point. What I want to do is now implement that interface in my car class. So let's head over to the car, and I'm going to add implements maintainable. And so let's go ahead and compile, and you can see I'm getting some warnings here in Atom already. And I believe that is because, that's because we need to implement those interfaces. But let's let the compiler actually tell us that, just in case you haven't started using all the extra features of Atom. Oh, and it was trying to help me with my typo there, implements, right? And I'm just ignoring it, so it's giving me red underline here, and had I paid closer attention, I would have seen that I had spelled implements incorrectly. All right, so let's go ahead, come back to the compiler, and try that again. All right, and the message here that I was expecting to see the first time around sounds similar to the abstract method issue that we ran into when we hadn't implemented an abstract method that existed on a superclass. Same thing here. Car is not abstract, does not override abstract method determine maintenance cost in maintainable. So because I'm implementing maintainable, I either need to make this class abstract, and that will get me around the issue and force the need to implement determine maintenance cost into the subclass, or I need to implement it here. And because this is my concrete class that I'm working with, I need to do that work here. So let's go ahead and add that method. And I'm going to do a little bit of copy and pasting here. So the comment really is pretty much going to be the same. And it'll give me the method signature without having to retype it as well. And just swap out that semicolon for my curly braces. And this really should have been maintenance cost. There we go. All right, so determining that maintenance cost, I would assume that that might be based on something like the make and the model and all kinds of information and the number of cylinders, for example. So I'm going to just simplify that a little bit, or quite a bit actually, because make and model maintenance costs are certainly going to be different across the board. But what I'm going to do here is just return, let's return 250 times number of cylinders. Of course, there could be much more information that goes into this. In fact, maybe in the real world, what would happen in my implementation, my chosen implementation, would probably be to go out to some type of web service like Edmunds, which has all kinds of information about vehicles based on the VIN number, go out and get information from them about maintenance costs for a particular vehicle. So that maybe would be what the real implementation would be here. For this, in this case, this works all right. Okay. And I'm going to make this a double just so that we get the level of precision that we're looking for. And the flag here that we're getting, abstract method, determine. So the warning that I'm getting is that, hey, you still have that abstract keyword hanging around. We need to get rid of that as well. If I've got the abstract keyword, I can't have implemented that particular method. And then let's go ahead and do the same thing. We'll implement this in airplane as well. So airplane extends vehicle, it implements maintainable. And we'll add in our new method here. And in this case, I'll make that a little bit more expensive, and it'll be based on number of engines. So I've written a bit of code. We should probably compile. And the compile looks good. Now let's update our vehicle factory to use that the maintenance piece. So here what I've done is created my list of vehicles, and I'm not going to make any changes there. I've got them placed into an array list. But what I am going to do differently is when I iterate through those, let's suppose that all I care about doing is getting the maintenance cost out and displaying that. And so because that's a method that is on maintainable, I can treat all of my vehicles that are in the list as maintainable. So let's see what that looks like. So I'm going to do a for loop here. And my object reference type, I'm going to use the enhanced for loop. So the object reference type is going to be maintainable. And I'm just going to call this item. And I could have called it maintainable as well, but that's a little bit, it's kind of a mouthful. So item is going to be easier for me to say as I'm coding this up. So for each maintainable item in my list, and that list is list of vehicles, then let's just display the cost. Cost of maintenance is, put our $sign in there, and then we'll add in on item, we now have the ability to, and the method was determine maintenance cost. So we can get that out. And you'll notice here when I hit the dot on item and looked at code completion, if I start typing here, I don't get a lot of options other than determine maintenance costs, because on that interface, it's really the only method that's there. All right, so we'll output on each of those the maintenance cost. So let's go ahead and compile and run. Oh, and I've got just a syntax problem here. So item, I'm not sure what I was doing here with my parenthesis, but item dot determine maintenance cost rather than the parenthesis there. So let's fix that up here. And I've got a couple extra parentheses hanging around here too as a result. All right, so we've got a problem. Incompatible types. Vehicle cannot be converted to maintainable. And the caret is pointing us to the list of vehicles. So list of vehicle, if we go back and take a look in the factory, we have defined that list to hold object reference variables of type vehicle. And vehicle doesn't know anything about the maintainable interface, right? I went ahead and implemented the interface on my two concrete classes. So I have a way around this. Really, maybe what I should have done is rather than implementing maintainable on the car and on the plane, maybe what I should have done is implemented that right on the vehicle. So what I'm going to do is get rid of that, and I could leave it, but it's kind of redundant, or it is redundant. So what I'm going to do is move that up to vehicle, and that will still force that maintainable requirement down to my airplane and my vehicle, or my car. So I'm going to go ahead and get rid of those. And because we're extending vehicle, which implements maintainable, that is then going to be enforced down on airplane and car. So let's save both of these guys and recompile. All right, so compile messages have gone away. Let's clear the screen. And then let's give that factory a run. And I think this was the vehicle factory test drive that we're now working with. All right, so we've got the cost of maintenance is 0 and 0, and then we've got a bunch of other output from other parts of the application. So why are we getting zeros? Well, remember that the code that we wrote was based on number of cylinders. If I haven't set the number of cylinders, I'm going to get 0 back. So I would need to go in and set number of cylinders in order to get better information back here. But the point of this really is that we can, in the factory, treat each of those items as a maintainable and be able to just call the determine maintenance cost. So if you think about maybe some kind of accounting application for a business that maybe has vehicles and it has other equipment that may need to be maintained, maybe in my accounting application, I would want to just iterate through my list of everything, treating them all as maintainable, just to figure out what are my maintenance costs for next year going to be, to kind of estimate that out. So that's a case where we would want to use maintainable rather than each of the various types. So if it was specific machinery like printers, for example, that's pretty different than my vehicles. I wouldn't want to treat all of those as vehicle when all I care about, or vehicle and printer, when all I care about is that maintenance cost. So in that case, it would make sense for me just to iterate through them as maintainable, which allows me to then call the determine maintenance. Otherwise, I would have had to have a list of printers and a list of my vehicles and a list of everything else that's maintainable separately. This allows me kind of in one swoop to do that calculation all at once if I wanted to summarize those. All right, so that is our first introduction to interfaces. Again, if you want to take a look at another interface that's used all over in Java programming, Comparable is one of the interfaces in the JDK that would be worth taking a look at. And if we have enough time, I may come back with a supplementary video to talk through Comparable so that you can see another practical application of these things implemented. Looking forward to hearing your questions on interfaces. We'll see you next time.